Good morning. We're going to continue with the topic of volume. Remember, the volume is the space inside some 3D shape. We are going to look at finding the volume of a prism. Firstly, we have to consider, what do we mean by a prism? Do you know what a prism is? Well, a prism is a 3D shape which has the same cross-section throughout the shape's height. The following shapes are all prisms. If we start with a rectangle as a cross-section and we extend it through a given length, then we end up with a 3D shape called a cuboid. Now, that's a prism because it has the same cross-sectional area all the way through. If we were going to slice that all the way through from the yellow rectangle at the top, we would have an identical rectangle at the bottom. So that is an example of a prism. It's a cuboid. Let's look at a second example. If we take a triangle as a cross-sectional area and extend it through a height, that's a prism. Again, the cross-sectional area is identical all the way through. It's that highlighted triangle in blue, and it's called a triangular prism. Let's look at a third example. If we take a pentagon and we extend it through a given length, then it's called a pentagonal prism, and the green highlighted area is the cross-sectional area. Now, we are going to find the volume of some prisms. Now, just as in cubes and cuboids, we consider firstly the area. In this case, the cross-sectional area. Then how many layers to find the volume of a prism. Now, I'm sure you all recognise this Toblerone bar, and that's a prism. It's a triangular prism. And if we put the dimensions in there, then the triangular prism, the triangle with base 4 and height 3, is the cross-sectional area. Really important that you can identify the cross-sectional area. So we would first of all work out the cross-sectional area, the area of a triangle, and it's highlighted in blue there. So the area is equal to a half of the base times the height. Can you see the base is 4 and the height is 3? So it's a half times 4 times 3, a half times 12, which is equal to 6 square centimetres. Remember, it's an area. Now, the volume of the prism is the area of the cross-section times the length, and it's highlighted there in blue. So the volume of the prism, the cross-sectional area times the length. Now, we've worked out the cross-sectional area in the previous part. It's 6. So the volume of the triangular prism is 6 times 20. That's the length. And it's a volume. So it's 6 times 20, 120 cubic centimetres. Remember, that's the space inside that Toblerone. The volume is the space inside the 3D shape. And in a prism, first of all, identify the cross-sectional area, find that area, and then to get the volume of the prism, it's the cross-sectional area times the length. Let's look at another example. Here we have a door wedge. And again, the first task you've got to do is identify the cross-sectional area. Now, can you see again, it's a right angle triangle there. Can you see that's the cross-sectional area? If you took that section all the way through, it would be common all the way through. Now let's put in the dimensions, 6 centimetres and 1 centimetre. So again, this is a triangular prism. It's a right-angled triangular prism this time. And again, we start by finding, once you've identified the cross-sectional area as a triangle, you begin to work it out. A half times the base times the height. So we put our dimensions in, a half times 6 times 1. A half times 6, 3 square centimetres. So the area, the cross-sectional area, is 3 square centimetres. We are asked to work out the volume of the prism. Remember, we said it's a cross-sectional area times the length. And that would be, well, we've extended it there. So can you see there that the length is 2 in this case? And if we put that in, That would be the cross-sectional area. We worked out in the previous example. The length is 2, 3 times 2, 6 cubic centimetres. So the volume of that prism is 6 cubic centimetres. Now that's going to be your task. You're going to be given the task of working out the volume of a variety of triangular prisms. Now the exercise is in your textbook, page 107 to 108, exercise 2, questions 1 to 9. Now I will write that in your assignment in the teams section, so you'll find it there, but it's page 107 to 108, exercise 2, questions 1 to 9. Really important that you look over this video once or twice before you start tackling these questions, and that you set them down exactly as I have in the slides. Okay, good luck, keep working hard. Thank you very much.